title of our research is Sugarcane Bagasse as Fiberboards.
The researchers of the study are Atienza Jasmine Denise, Bautista Giancarlo, Panganiban Charlie, and Ramos Alexander.
The contents of this research are introduction, statement of the problem, methodology, results and discussion, conclusion, and recommendation.
Sugarcane is a species of tall, perennial grass that is used in the production of lots of products. Aside from producing sugar, it also gives ethanol, biodegradable products, energy generation, and food for animal production. Sugar canes are abundant in our country, especially in places like Negros Island, bringing a relatively huge portion of income to our country. The production of sugarcane-based product produces a material called sugarcane bagasse. It is often used to produce heat and electricity, but it can also be used as cattle feed and for manufacturing disposable food containers. But according to Applied Microbiology and Bioengineering of 2019, every ton of sugarcane ground in sugar and ethanol production generates an average of 50% moisture. 250 to 270 kilograms of bagasse are produced. They are mostly wasted, so we need to think of ways on how to make use of them. So the researchers thought of making them into fiberboards. The main reason why they chose sugarcane bagasse is because it has fibers. It is eco-friendly and helps in reducing bagasse waste that was produced by sugar factories. Therefore, this study will help the people and the researchers if sugarcane bagasse can be used as fiberboard. This experiment is focused towards evaluating how sugarcane bagasse can be used as fiberboard and its characteristics. The researchers would first think of the components that would need to form a usable sugarcane fiberboard. After that, they would test its characteristics. They would test how much weight the fiberboard can carry by putting objects of various weights on it. They would also observe the difference in density of a normal and sugarcane fiberboard by soaking them in water and testing their weight. This would be called the water absorption test. This test would test either the sugarcane bagasse is an appropriate substitute material in making fiberboard or not.
For the statement of the problem, number 1 is, what are the components of sugarcane bagasse to be made as fiberboard? Number 2, what binder will be used in making these fiberboards? Number 3, how much weight can fiberboard made from sugarcane bagasse can hold based from the given below? 500 grams, 1000 grams, and 1500 grams. And for the last problem, is there a significant difference in weight between a normal fiberboard and a fiberboard that was made from sugarcane bagasse by using water absorption test?
For the methodology, the researchers used different materials and equipments to make the sugarcane bagasse fiberboard. These materials are 250 grams of styrofoam, 1/2 liter of gasoline, 1 sack of sugarcane bagasse, 500 grams, 1000 grams, and 1500 grams of sand, 1 weighing scale, and 1 metal tray as a molder. The subject of this study is testing the sugarcane bagasse effectiveness as a material on fiberboards that could identify if a sugarcane bagasse is an effective material to enhance the quality of a fiberboard. Sugarcane bagasse are collected from sugarcane factory at Caloocan, Balayan, Batangas. It will be mixed with styrofoam and gasoline that will create sticky paste as its bonding agent and will be pressed to create panel products. The researchers observed and tested the fiberboard by strength test and water absorption test and found the conclusion to this research. The researchers make sure that the result is based on what is observed in the experiment. By gathering the data that they needed, the researchers will use paired t-tests to know the significant difference of the sugarcane bagasse fiberboard before and after it was under the water for 3 hours.
For the results in discussion, there are two tests: the strength test and water absorption test. In the strength test, fiberboard that was made from sugarcane bagasse were tested. The size of these fiberboards are 9 inches by 5 inches, and it weighs 75 grams. This test is to check if it can load 500 grams, 1000 grams, and 1500 grams of sand above it for 10 seconds. There were 3 treatments in Table 1. Treatment A weighs 500 grams, Treatment B weighs 1000 grams, and Treatment C weighs 1500 grams. All of these treatments carried their corresponding weights. Also, the researchers go to a water absorption test to test the weight of the sugarcane bagasse fiberboards before and after it was under the water for 3 hours. There are 3 samples in this test. After the test, the researchers will use paired t-test with a significance level of 0.05 to know if there are significant difference on the weight of the sugarcane bagasse fiberboards before and after the water absorption test. For Table 2, there were also 3 treatments. For Treatment A, it weighs 10 grams before water absorption test. Treatment B weighs 15 grams and Treatment C weighs 20 grams. After water absorption test, Treatment A weighs 17 grams, Treatment B weighs 30 grams, and Treatment C weighs 42 grams. To get the difference, weights before water absorption test were subtracted to weights after water absorption test. For Treatment A, 10 minus 17 is negative 7. For Treatment B, 15 minus 30 is negative 15. And for Treatment C, 20 minus 42 is 22. The formula of paired t-test is T is equal to summation of D over square root of N, open and close parenthesis, summation of D squared minus summation of D, open and close parenthesis squared over N minus 1. By substituting all the given, it results T is equal to negative 44 over square root of 3 times 758 minus negative 44 squared over 2. And by multiplying 3 to 758 and squaring negative 44, the answer will be 2274 minus 1936. After subtracting 2274 minus 1936, the answer will be 338. And the equation will be negative 44 over square root of 338 over 2. After that, by dividing 338 to 2, the equation will be negative 44 over square root of 169. By performing the square root, the answer will be 13, and the equation will be negative 44 divided by 13, and the final answer will be negative 3.38. To get the degrees of freedom, the researchers subtract the number of treatments to 1. And by looking at the t-tabular value at the section of 0.05 and degrees of freedom 2, the value is negative 4.303. Also, its p-value is 0.07 and it is greater than 0.05, which means that there is no significant difference in weight of the sugarcane bagasse fiberboard before and after water absorption test.
Conclusion: Philippines is one of the exporter of sugar in the world. It is also a rich country in terms of material and making furniture. People always knew that only wooden fibers can be used in making fiberboards, yet sugarcane bagasse is also a good alternative for those wooden fibers. With respect to these claims, the researchers proceed in making a study about how sugarcane bagasse can be made into one. With the help of melted styrofoam and gasoline as a bonding agent, the researchers successfully made a fiberboard out of sugarcane bagasse. Then, Researchers proceed in two different tests called strength test and water absorption test. On the first test, the fiber board holds 500 grams, 1000 grams, and 1500 grams of sand. Meanwhile, in water absorption test, after the fiber board was soaked in water within 3 hours, researchers gathered the weight of the fiber board before and after it underwent the test. The researchers conclude that there were no such significant difference in weight. Therefore, with the accurate bonding agent, different tests, there were such possibilities for sugar canes to be made into fiber boards. Recommendations. For the recommendations of the study, researchers recommend to first use different binders. Since the fiber board will not be made without a bonding agent, the researchers recommend to seek something that could be a great alternative for styrofoam and gasoline. Since gasoline and styrofoam can make fibers stick to each other, there will be always something that can do more or at least like what the current binder did. Second is to conduct more tests into the sugarcane bagasse fiber boards. This is because water absorption test and strength test will not be enough to prove that sugarcane bagasse can be made into fiber boards. The researchers recommend to conduct tests like density test and thickness swelling test. Third is using of high technology machineries and equipments in making these sugarcane bagasse fiber boards. It is because the researchers had a hard time making these fiber boards manually. There are a lot of processes in making these fiber boards. Hence, it is a great recommendation if there are different machineries in making fiber boards. Last is the future of the studies. This study would be a great help for the future researchers to have a great understanding and strengthening their knowledge about this study. Yet, this study would be a great opportunity for the researchers to seek of different studies and find a gap of it.
And that is all for the final research presentation of our group. Thank you.